Hello to everyone, I'm Irfan and welcome to this new session. In this video, we wanted to create a model, a name for plumbing system with a bolt and nut connection. So let's start doing this. At first, we should sketch a front plane and draw some lines up like this. Okay, and then we should set some dimension for them. Okay, I set 5 centimeter for here. Let's say 10 centimeter, 5 for here. Okay, and then exit the sketch and open top plane, and then you should draw a circle right here for and set the pipe diameter 5 centimeter. It's equal somehow like 2 inches. Okay, so and then you go to the features and you use this. You set the geometry, and this is the pathway for this geometry. I set this, and this one for here. As you can see, the knee is now created, and also you should set some theme for your actually name. So I set the value. Okay, that's good. Now new is created, and for the connection part, I sketch here and draw another circle right here, and let's set 7 centimeter for here, and then go to the features and extrude this part, and let's say it's equal to 0.5 centimeter. Okay, and also it's better to also draw another circle. Let's say so. Now 5, and then the extrude cut. Okay, now it's created. Okay, that's perfect. So, and also you should do the sketch again, and also draw some small circle for your bolt and nut connection, something like this. I set the value 0.5, and distance from here is 3, and also you have to use this part. I said okay, and here we have to set the sketch, and here you have to show your path. As you can see, I choose this line of the circle, and here you can set the number of this circle, how many you want. For example, you can put 8 or 10. We can set 10. Okay, and then we use extrude cut. Okay, and we have to repeat this part for here. Okay, let's sketch again. set the value 7 centimeter for here and extrude again. Let's sketch again 5 centimeter for the diameter and use this extrude cut and set OK. Sketch here again. .5 centimeter, and the distance from here to here is equal to 3 centimeter. And then you should use this pattern. Let's click here, and for the sketch, I click the circle, and I set the number to 10. And then again, extrude cut. Okay. Now the model is kind of ready. And from here, now the view is good. From here, you can set the material for your knee. I click here, edit material. You can set, let's say carbon. You can see different material right here. Or maybe, let's see, let's set iron. Okay. Or maybe carbon steel. And let's get some render for this geometries. And also let's get some render for this geometry. So for that, you go to the SolidWorks add-in and click here. Another tab is right here, and then you can set some option from here. For example, the quality of the render. There's two render at for your system. There's a preview and the final render. I set the final render on the maximum, and the preview is on good. Okay, that's good. And here is it. And okay, and I click on the final render, and also I can add a camera and see the perspective of my view. Okay, that's good. So let's click on the render, and then let's see. Okay, now you can see the render is ready and the quality is very good. And in the next step, we want to simulate the flow simulation inside this knee. So let's start doing this. Okay, for flow simulation, you go to this part and you should use some cap for here and also here. You close the system and then click here and then click on the wizard and set a name for your system flow simulation, and then click the next, and also gravity, the point, the direction of the z is 0, and then the direction of the y is equal to negative 9.81. Okay, click on the next. And you should also set your liquid. Here we have got the water, and in liquids, scroll down and choose the water and set on click on the add and then next, finish. Okay, we use the cut and cut your geometry somehow like this. Then click OK and hide this computational domain. OK, and also you should set some boundary condition from here, and you should set your inlet mass flow, or it depends on the flow rate, which is m dot, or your velocity. Okay, we can set the inlet velocity for here, and let's say is equal to 3 meter per second. And the thermodynamic parameter we can set, okay, it's 320 Kelvin. And also for the outlet, you should set another boundary. We click here again, and let's say total pressure, and click here. Okay. And for your goals, we can set some global goals, and let's say we need the velocity, the average, or we can set the minimum or the maximum. We need the velocity average, and also, okay, and let's set also pressure. Okay, static pressure, it's here. Just click OK, and then run the system, run the simulation from here. Okay, we have to wait. The calculation is finished. Okay, perfect. And from here, you can display transparency. You can set a value for your transparency of your geometry, something like this. And I turn off the cut and then go to the result, and let's see, cut plot insert, and in the front plane, okay, we have got the pressure or the velocity. We can set the velocity here, and let's say okay, front plane. Now we can see the pressure of the fluid inside this knee. And also we can insert another cut plot for the pressure. Okay, let's turn off the cut plot 1, hide it, and we can see the pressure of the fluid inside this knee. Okay, that's good. And also we can turn off it again, and also we want to set the flow trajectories from here, and click on the insert, and here you should choose your geometry, and also we want to see the velocity of the fluid, and the number of the arrows is equal to 200. We can set 250, whatever you want, and then click on OK and OK. We can kind of reduce the number of arrows from here. Let's say 80. Okay, now it's better. It's better, and let's play the system. Okay, now you can see the different velocity inside this knee. So thank you for watching this video. If you have any question, please comment for me and I will answer to all of your questions. So good luck.